Hello boys, I Dr. Pradeep Kumar Srivastava welcoming to all of you in my class Water Resources Engineering. Today's topic is the catchment area formula and flood hydrograph rainfall analysis. Today we will discuss on the three matters. First, catchment area. Thereby, in my previous lecture, I think you have aware what is the catchment area. But today's topic is catchment area formula. But today I also start from the catchment area. What is the catchment area? Thereby, catchment area, which area where the rainfall has collected in the one place. This is the catchment area. Suppose this is the area and entire rainfall after the start of flushing, it has collected in the one place that is called river or nala, and this area, my dear boy, this area, it is called catchment area. Clear? So how we will this measure? What is the formula of this? Next, flood hydrograph. Next, we will discuss flood hydrograph. How much water will be flood come and when it will be rise, the develop of the flood. So this is the flood hydrograph. And third, rainfall analysis. Okay, about the rainfall. So thereby, let us start our topic. Actually, buildings plan offer the assist way to calculate your roof surface area. After all the number, should all the one, there this calculation option will also give you very accurate result. Google Map or other observed mapping software can also be used to calculate your roof surface area. This accuracy of your result will depend upon which tool you use. However, it should give you a good rough calculation. Alternatively, you can simplify, head outside with a tape measurement and roughly measurement the size of your roof at a ground level. This will provide through calculation is still useful enough for the process. Calculating your catchment capacity. Roughly speaking, 1 millimeter of rain over 1 square meter of the roof equal 1 liter of water. So, dear boy, this capacity can be calculated using the following formula: annual rainfall in millimeter into roof surface area in square meter. So roof catchment capacity, this is an important figure to understand. So you can design a rain harvesting system and choose a tank size that will be meet your water volume requirement. The natural feature of folding occurs when excess rainfall cannot be absorbed by the receiving soil or discharged fast enough by the stream network. In this condition, the river sees a depth rising until the water can overstop at bank and spread throughout the adjacent floodplain. An area where the river had surrounded by relatively flat land, that the flood plain can therefore be rapidly covered with a large experience of shallow water. After the water retreats, flooding depends still on the flood plan and impervious its fertility over a decade as a consequence frequently. So flooded area used to attract agriculture and therefore human development near the river where soil are rich. Nowadays, human activity have been changed. Agriculture not at the center of our society anymore, and flooding is now only seen as the natural disaster. When water separates throughout urban area where population and economic activity are usually concentrated. So flooding, when reaching particular, their hold can have disastrous consequences in both terms of life and money. In poor rural countries, every one event can indeed cause many deaths. Like example, in Venezuela, December 99, where approximately 10,000 people died and 150,000 become homeless. And developed country where river prone to flooding are managed carefully and damage are usually more economic than human. Unfortunately, tragedy can also happen where people feel suffer. And the last example was the turbine flooding caused by the hurricane Katrina, New Orleans, August 2005. So where overtopping of the tank or overtopping the bank caught about the thousand of death and 2000 billion worth of damage. The frequency, height, and magnitude of flood appear to have increased in the last decade. Climate change, which are more and more political and all over the world, are often held responsible of change and storm pattern and therefore in flood frequency increase. So another contributing factor is the consistent spreading of Azerbaijan area over the rural land with the construction of concrete where soil and one swatch which contribute to increase the valuability of the river catchment. Solution to flooding problem have been introduced with the example the structural solution that attempt to eliminate flooding in a specific area and using engineering work such as flood control, dams, like rendering of river beds. This could, however, often the result in the unwanted environmental, hydrologic, economic, and ecological consequence. On the other hand, non-structural solution aim at lowering the valuability of an area and include land use regulation and flood bearing system and flood bearing costing system. So flooding and river riding problem, which are mainly driven by the excessive rainfall pattern on given catchment, are indeed and more easily predictable than other natural disaster. Three earthquakes, this means volcanic and European. It has therefore become important to gain a good understanding of rainfall variation in the different area where flooding are current and assess now the excess rainfall will be drained to stream network and the past decades many rainfall runoff provide have been developed with this goal. As with many other catchments in Ireland, the Monastir Blackwater is subject to frequent flooding problems. This project deals with understanding of rainfall pattern over this area and the modeling of the hydrologic process. The occur when have respiration cause important volume of excess rainfall. Hydrology is the science of occurrence, movement, and the distribution of water. So even below the land surface in the atmosphere and surface water hydrology, groundwater hydrology. So first we will discuss now what is the catchment area. So the area of land clearing into a stream of a water course and keeping the location is known as catchment area, also called a drainage area or drainage basin of watershed. So this is the catchment of the river area. The water area of the catchment has come in the zone, and it is the make the entire river catchment. This is also picture you can see entire the blue color has been looking in river flowing system, and entire all the thing, all the webs, all the his leaves is showing the calculating of water. Now water budget equation. So from the continuity equation for water, that is the mass inflow minus mass outflow and change in mass storage. So water budget of catchment for a time interval delta, and that is the written as PRGET is equal to delta S. Water where P is equal to participation and R is equal to surface runoff. G is equal to net groundwater flow or out of catchment. So E is equal to evaporation and T is equal to transpiration and delta S is equal to change in storage. All term in equation may have the dimensions of volume of depth over the catchment area. Over the catchment area. So this is the example, and this is example 2. Two are examples. Now we will discuss on the theoretical topic, hydrograph. It's a graph showing the rate of flow discharge very time passed in the specific point in a river or other channel or conduit carrying flow. So it can also refer to graph showing the volume of water recharging a particular outfall. And graphs are commonly used in the design of sewerage, more specifically the design of the surface water sewage system and combined sewers. Rising limbs. The rising limbs of the hydrograph, also known as the concentration curve, reflect prolonged increase in the discharge from the catchment area. So typically in response to rainfall event. Now recession or falling limb. The recession limb extend from the peak flow and rate onward. The end of storm flow, aquatic flow or direct runoff, and the return to groundwater diverted flow. So base flow is often taken at the point of infection of the recession limb. The recession limb represent the withdrawal of water from the storage built up in the basin during the earlier phase of hydrograph. Now peak discharge. The highest point on the hydrograph when the rate of discharge is greatest. So that which called the peak discharge. It means I think you should know about the peak discharge. This is the peak discharge. This is the peak discharge. Dear boy, on the condition when the rainfall is starting, the discharge has increased. And after the quite of rainfall, it has been down. So this is the peak. Clear? Now lag time. The time interval from the center of mass of rainfall access to the peak of the resulting hydrograph. So time to peak, time interval from the start of resulting hydrograph. So discharge, the rate of flow, volume per unit line, and passing a specific location in a river or other channel. This is the peak. This is the runoff discharge. This is the diagram of peak. So this diagram you can see that. Now unit hydrograph. So now we will discuss what is the unit hydrograph. So dear boy, hydrograph usually consists of fairly regular lower portion that change slowly throughout the year and the rapidly fluctuating component that represent the immediate response to the rainfall. The lower slowly changing portion is the term based how the rapidly fluctuating compartment is called direct runoff. The amount of runoff resulting from 1 unit and 1 centimeter, 1 mm, 1 feet, etc. of rainfall excess is essentially a tool for determining the direct runoff response to rainfall. Once you know the watershed response to on the storm, you can predict. So what is the response of another will look like. Now basic assumption of UH. So the effective rainfall of informally distribution within us duration and the effective rainfall is informally disturbed over the whole drainage basin. The base duration of direct runoff hydrograph due to an effective rainfall of unit duration of constant and the coordinates of the DRX are directly proportional to the total amount of DR of each hydrograph. For a given basin, The runoff hydrograph due to a given period of rainfall reflect all the combined physical characteristics of basic time event. Remove the how to get the unit hydrograph. Okay, so remove the base how you mount from the hydrograph and calculate the net rainfall by removing the inflection of the rhetorical storage, the hydrograph. Scale the new hydrograph unit to yield a unit hydrograph for say 1 inch for 1 hour and 1 by 2 in hour for 2 hours or 1 by 3 per hour or 3 hours. As unit hydrograph has 1.0 inch of the direct runoff of storm duration. Now storm duration. So here we start 2 inch for 2 hours net rainfall, that 1 inch per hour for 2 hours. To get a 2 hour UH, we want 1 by 2 inches hour or 2 hour. So we have to divide the hydrograph ordinates. We divided each hydrograph ordinate by 2, resulting in a 2 hour per unit hydrograph, that is the 1 inch of direct runoff total form the 2 hour storm make an 1 hour. Now synthetic unit hydrograph. Synthetic unit hydrograph. So what is the, my dear boy, synthetic unit hydrograph are derived by relating hydrograph characteristics such as the peak flow, base time with water set, and characteristics such as area and time of the concentration, and using dimension unit hydrograph and based on the water source storage. So unit hydrograph is applicable only for gauge and water set and for the point on the stream where data are measured. For other location on the stream in the same water set or for nearby ungauged water set, synthetic produce are huge. So Snyder method. Snyder method always the component of log time, unit hydrograph duration, unit hydrograph peak discharge, hydrograph time with at 50 and 75 and peak flow. Now log time T L time is the center of rainfall and access to unit hydrograph peak. So this is the formula T1 is equal to C1 under bracket LLC to the power 0.3. So where L time hours C1 and along the main channel, the point nearest to water set centered. So this is the calculation Snyder method, this is the calculation. Hydrograph introduction, it is the science which deal with occurrence, circulation, and distribution of water on Earth surface and its atmosphere. So hydrometry, it is the science and practice of the water flow measurement, and hydrological cycle. It is a cycle in which water move from the phase to another, having and different side time in each phase. Now, residence time. This is the time which is taken by water and practice in crossing the particular phase of the hydrological cycle catchment area. The area dragging into the river of a stream is called the catchment area. Okay, clear? Wait. Suppose, my dear boy, this is the hill. So, this area is a catchment. So this area is another catchment. This river has come, and this river. And this is the practical of the catchment. Now, ridge. So this is the line which demarcates one catchment area from its neighboring catchment area. So there is called a device or water divide and water shed in UK. Water budget equation. So change in storage of mass inflow, so mass outflow. The equation is based on the low conservation of mass. This is the calculation. Now, this is the up. Now you see runoff. This is the area where rainfall will be trapped and runoff will become after the saturation of entire command. Now runoff computation. So heavy losses and huge drainage taking place in the watershed due to occurred of flood. Flood is produced due to heavy rainfall, and the estimation is dependent on the rainfall intensity. Rainfall intensity, type of soil, shape and size of watershed, and context of the watershed at the time of rainfall, slope watershed. Now, method of estimation of runoff. So, empirical formula, envelope curve, physical indication of the past flood, and the rational method, and the parabola maximum participation RMP, and chart, and rate curve, and hydrograph method, and SSCN method, and flood frequency analysis. Now runoff computation. So this is the empirical formula, and taken formula is equal to discharge is equal to CA catchment area, CA oblique 3 by 4, where Q is equal to design flood area, A area is equal to catchment km square, and C becomes constant, and North Indian plain and North Indian hilly region, central India, and coastal Andhra of Odisha. Now empirical formula. So Ray formula is equal to Q CA 2 by 3, where Q is equal to design flood. This is the meter cube upon second, and area is the catchment in the kilometer square. Area within the 80 kilometer from the east coast, and 6.8 area within the 80 to 160 kilometer from the east coast, 8.5 limited near the hill 10.2. This is the runoff equitation. And now major limitation of UG empirical formula is the subjective decision about the value of C to be adopted. This is the envelope curve. Now runoff computation. So physical in direction of post-past flood and sand monument situated near the bank of river always bear the mark to record on the past flood, and the flood discharge obtained from the formula discharge is equal to A into V, and where A is equal to cross section of the valley during dry season, and V is equal to velocity of flow, and can be calculated from the money, and usually factor of safety about 1.5 is used to obtain maximum. Now rational method. It is the most effective in urban area with drainage area of less than 200 acres. The method is typically used to determine the size of storm, sewer, channel, and other drainage sticker. So Q is equal to CIA upon 3.6. Rainfall intensity can be found from the intensity, duration, frequency curve corresponding to time of time of concentration. Of this is typical IDF curve. Runoff computation, and this is the value of C constant decided for every figure. Now runoff computation. So rational method assumption, the drainage basin characteristics are fairly homogeneous and rainfall duration equal the time of concentration and result of the greatest peak discharge. The time of orientation is the limit required for runoff to travel from the most distant point of the watershed to outlet. Now time of the constitution, hydraulic length and velocity. Runoff computation. So rainfall, rational method. This is the formula. T is 0.0032 L02 upon S 0.355, where this system is adopted. A parabolic maximum precipitation chart. So RMP chart have been prepared by Meteorological Department of India for same state and such as Punjab, Haryana, Delhi and Rajasthan using the following method. So meteorological method, statistical study and rainfall data. Now rating curve. It is the graph of discharge various stage of given point on the stream, usually at the gauging station where the stream drainage is measured, access of the stream channel with a flow meter. So unit hydrograph method. It is the near model catchment where the use find out the volume at direct surface runoff, that is the DSR, turn to 1 centimeter of rainfall, excess it rainfall, sum of the catchment prolonging and same of excess rainfall. The ordinate of DSR will be twice as much the UH and unit hydrograph. So coordinate and the volume of DSR will be two limit of the volume of the unit hydrograph. Assumption. The rainfall of the spatially uniform intentionally with the specialized mean and the effective rainfall is unnormally distributed throughout the whole area of discharge basin. Now, unit hydrograph, you have read, and the curve number is based on the area as a hydrologic soil and group land use treatment as a hydrologic condition. And this is the formula of CN method. And now hydrologic soil. HSC group A, now runoff potential soil with logic infiltration rate even when thoroughly wetted. So final infiltration rate greater than 0.3 in inches per hour. So HSC group soil with the moderate infiltration rate than the thoroughly wetted, and final infiltration rate is 0.15 to 3.0 inch per hour. Now HSC group, so soil with the soil infiltration rate when the throughout wetted, final infiltration rate and 0.05 to 0.15 inch per hour. And HSC group, the high runoff potential and soil with very slow infiltration rate, and when the thoroughly wetted, final infiltration rate less than 0.05 inch per hour. So dear boy, you have read about the topic, and I want to ask you some MCQ about this topic. So let us start our MCQ. Actually, a multi-purpose reservoir is the one which is designed for which purpose? And your answer is looking on your screen. So which are correct answer? Thereby correct answer is B, and the planned and the constructed to serve various purposes. And a rain gauge should be preferably be fixed near the building. So which are correct answer? Correct answer is C, in an open space. A repelling ground is aligned. So which are correct answer? That is the pointing upstream. Correct answer is A. Now a hydroelectric scheme operating under the head of 80-meter well be classified as. So which are correct? Correct answer is C, high head scheme. And now a land known as the waterlogged, and when the permanent dwelling point is reached, which are correct answer? Yes, correct answer is C, capillary fringe reach the root zone of plant. And next question, a hydrograph is graphical representation of a rainfall intensity and time. So which are correct answers? Correct answer is A. Good. And next question, 70% index of the witness mean. What is the mean? Yes, it is the correct answer, and correct answer is B. So rare deficiency of 30%. Now a deep well is always deeper or shallow well. So which are correct answer? Correct answer is B. Has more discharge than a shallow well. And now next question. A current meter is used to measure the velocity of flow of water. And which are correct answer? Correct answer is A. Velocity of flow of water. And last question. A divide well is provided for which is correct. So correct answer is A, at the right angle of axis of here. And this is the references which have taken from this lecture from website. And this is the books for reference. This is also web references and book references. And thank you for taking interest in my class. You are welcome in my next class.